Today we're going to look at a few practice problems to help us better understand how to solve related rate problems. Now, related rates can be a very difficult thing to start with. However, they can also be very easy if you just understand two things. The first thing you need to understand is that derivatives are just representations of rates, of maybe how fast or slow something is increasing or decreasing. And then the second thing that you need to understand is how to do implicit differentiation. Now, if you don't know how to do implicit differentiation, I already have a video made that explains that whole concept, so I would 100% watch that first before continuing to watch this video. So now moving forward, we're going to just assume that you understand implicit differentiation and get into the related rate problems. So let's look at our first problem. The length of one side of a rectangle is always 3 times the size of the shorter side. The shorter side is increasing at a rate of 2 units per second. How fast is the longer side increasing? Okay, where do we start? Well, the first thing I'm going to do is label the stuff that we're already given. So we're told that we have a long side and a short side, right? And the long side is 3 times the size of the shorter side. So let's say our shorter side is x. Let's just call it that. And then our longer side is y, which is 3 times the size of the shorter side, so that means it's equal to 3 times x. We're given the shorter side is increasing at a rate of 2 units per second. Now remember how I said that derivatives are just representations of rates? That means when x is changing with respect to time, since we're doing this at a rate of units per second, dx dt, so the rate that x is changing with respect to time, is going to be equal to 2. So that's another variable we can label. Dx dt is equal to 2. We're looking for how fast the long side is decreasing, so y. So what we're looking for is dy dt. Now how do we find that? Well, we already have a representation of y in that y is equal to 3x. So if we differentiate that entire equation with respect to time, then we can solve for dy dt. So dy dt is equal to 3 dx dt. Now, lucky for us, we already know that what dx dt is equal to. So we know that I wrote dy dx. This is supposed to be dy dt. So dy dt is equal to 3 times 2, which is equal to 6. So we know that our longer side is increasing at a rate of 6 units per second. Now let's look at another practice problem. So here's our second problem. A spherical ball's volume is increasing at a rate of 32 pi cubic units per minute. Let's say cubic, not cubis. How fast is its radius increasing when its radius is 2 units long? Okay, so again, let's look at what we're given here. So we're given how fast our volume is changing, right, with respect to time. So volume is v, therefore we're given dv dt. So we have dv dt is equal to 32 pi. How fast is its radius increasing when its radius is 2 units long? Okay, so we're given that r is equal to 2, and we're looking for dr dt. How can we find that? Well, we're going to do like we did last time. We're going to set up an equation that relates volume to radius in this example. And so the volume equation of a sphere, if you don't know, is v is equal to 4/3 pi r cubed. So since we're looking for the derivative of r with respect to time, let's differentiate this entire equation with respect to time. So v is going to become dv dt. And then the right side of the equation, 4/3 pi r cubed. When we do implicit differentiation, we're going to get 4 pi r squared dr dt. And now we can plug in the variables that we've been given. We know that dv dt is equal to 32 pi, and we know that r is equal to 2. So we have 32 pi equals 4 pi times 2 squared dr dt. Let's simplify the right side of that equation. We have 32 pi is equal to 4 pi times 2 squared is equal to 16 pi dr dt. And now if we divide 16 pi from both sides of the equation, we get that 2 is equal to dr dt. And just like that, we found the rate that its radius is changing when the radius is 2 units long. Now I want to recap what we did in these past two problems. We were given some variables and we defined those so that way we could see them. We set up a relationship between the two variables we were given. In the first one, it was y and how it's related to x. In this one, it's volume and how it's related to r. We differentiated each question or each equation with respect to time, and then plugged in the variables we were given to find the variable we were looking for. In the first case, dy dt, and in this case, dr dt. If you watched to the end of this video, I really appreciate it, and I hope you learned something.